Hi all, in this video I'll be guiding you through the tutorial questions from 3.1, question 1b and question 2b. This was your homework, so let's go through the answers. Now 1b, what is the question? It says that state the period, group and block for each of the following element. And as I told you in class, first it's definitely easy to determine the period, then you move on to the block and finally determine the group. Okay, so for A, all you have to do to determine the period is to look at the highest principal quantum number, that is 3. And what block would it be? I mentioned that you have to see the last electron entering. For here, the last electron entering would be in the p orbital. Therefore, it would be in the p block. And finally, what would be the valence electron configuration? Valence electron configuration would be 3s2 and 3p6. So that will give us a total valence electron of 8 electrons, and since it is in the p block, that would mean the group we have to add 10. It would be group 18, right? So here you can have a look at the answers. So for A, it's best you do a table, and you can see that's from period 3, group 18 and block B. Now let's look at B. So what do we have for B? B, again, the highest principal quantum number, as you can see here, would be 4. All right. And last electron entering, in this case, would be in the s orbital. So it's from s block. And what would be the valence electron configuration? Valence electron configuration will be only 4s. So here we have 2 valence electron and it's from the s block, so simply means it's going to 2. All right. And as for C, we can straight away look at the answers. So C, it's from period 4. All right, D block. Why D block? So please remember here, this is a transition element whereby first you would fill up 4s and then you would fill the 3d orbital. So the last electron is entering the 3d orbital, which brings it to be a D block element. And then what would be the valence electron configuration? Valence electron configuration would be 3d3 and 4s2, giving us a total of 5 valence electron. And since this is in D block, it would be simply group 5. Okay, so similar pattern for option D, which is we have the highest principal quantum number to be 4. The last electron entering would be in the D orbital, therefore it's a D block, and group would be group 9 because the valence electron configuration, as you can see from here, it is 4s2 and 3d7, giving valence electron, total valence electron to be 9 electrons, and thus group 9. Okay, right, easy, yeah? Right, next let's look at this table over here. We are given 4 elements PQRS, and the group and period is given as well. Okay, so first we have to write the configuration and state the block for all the elements. Now, group 16 means how many valence electron? 6 valence electron. And period 2 means the highest principal quantum number would be 2. So how can we write the valence electron configuration? Bagaimana kita nak tulis valence electron configuration? Kita mula daripada 2. Okay, kita nak isi 6 electron, so we would start from 2s2, tinggal lagi 4 electron. So we move on to the p orbital, therefore we would have 2s2, 2p4. Okay, so this is the valence electron configuration. Jadi, what is the meaning of that? What should you understand? Kalau ini valence electron configuration, maksudnya orbital-orbital yang ada dekat dalam dah isi penuh, which is only 1s2 in this case lah. Therefore, the configuration of P is 1s2. Oh, sorry, you can write it over here. 1s2 and then 2s2 and 2p4. And since the last electron that entered was in the p block, p orbital, therefore it is p block. So let's do that again for Q. So Q has got 8 valence electron. How do I know 8 valence electron? Because it's from group 18, and since it's in period 2, okay, what would be the valence electron configuration? It would be 2s2 and 2p6. So since this is the valence electron configuration, that means whatever in front should have been fully filled, and that is the electronic configuration of Q. And again, it is in the p block. Now let's look at R. R is from group 1, so the valence electron is 1, and it's in period 3. So period 3 means principal quantum number saya 3. Okay, and I would start with the s orbital, so 3s, and I only need 1 electron. I only have 1 electron as valence electron, so my valence electron configuration would be this. So bila valence electron configuration saya 3s1, maksudnya dalam tu semua dah diisi, the inner electrons are all filled up. So 1s2, 2s2, 2p6. Alright, so that would be the full configuration of R. And finally for S is from group 17, 7 valence electrons, and it's from period 4. So what can we understand about period 4? So period 4 means principal quantum number 4, 7 electron, 4s2 and 4p5. Okay, and all the inner electrons must have been fully filled. So what would be it? It would be 1s2, 2s2, 2p6, 3s2, okay, 3p6, 4s2. Selepas tu we would have written 3d10, and then only comes 4p5. Okay, so don't forget this 3d10, which is filled up after 4s. Okay, after 4s2, 3d10 baru 4p5 will be present. Okay, and you know that once 4s orbital is filled with electron, it goes higher in energy compared to 3d. So kita tulis macam ni lah, the electronic configuration. And since the last electron entered the p orbital, so it's from p block. Okay, so you have the answers on the right as well, as you can see. And finally, what is the electronic configuration for the most stable ion of P, R and S? So P, as you can see, has got 6 valence electron, so it needs 2 more to have a completely filled p orbital that is stable. Therefore it would receive 2 electrons and become p2 minus. As for R, R is from group 1. We all know group 1 forms a single positive charge. Therefore it would be easier for R to release its valence electron and then form a configuration of 1s2, 2s2, 2p6. And finally for S, so what would be the most stable ion for S? That would be to receive 1 electron into the 4p orbital, because it's from group 17, and we all know group 17s are halogen, right? So halogen have got a single negative charge. Okay, I hope with these two tutorial questions you are much more clearer on how to write electronic configuration if period and block are given, and also if electronic configuration is given. I hope now you are much clearer to state the period, group and block for the elements. Okay, so you can use this knowledge to complete the first part of your assignment. Thank you.